this time is on factoring. We have a couple things with factoring that we're going to do as review. And we're also going to add how we can find a GCF in a more consistent way so that none of you are left guessing as to what the GCF is. Because that's where a lot of students miss points, is that they don't actually get the full GCF when we're factoring. Okay, so we're going to do a few things here just to sort of review some past standards. They're things I've been highlighting on your list, but some of you might benefit from having the info on. And then we're going to carry that info over into our actual first piece of factoring, which is going to be factoring a GCF. Okay? So today is Tuesday. Hey guys, like, we should be writing these down. We should be taking notes. The other conversations are done.
I was just asking him how his day was.
Yeah, exactly. Okay, so the first type of factoring that we should be able to do is we should be able to prime factor. Prime factoring is one of those things that like always bothers me, because I ask students if they can prime factor and they say no, and I say, well, can you do the tree thingy? And they go, oh yeah, that I can do that. That is prime factoring. Okay, so if we want to prime factor something like 40.
Why would you want to prime factor 40?
It's important to be able to do other things later. Okay? So I think like most things, guys, none of this on its own is helpful. Factoring by itself is silly. Prime factoring by itself is silly. Prime factoring helps us do other things. Factoring GCFs helps us do other things. Okay, so on its own, it's pointless. All right, but if we want to prime factor 40, babe, take it out. I want it. Nope, completely away. Off your ears, up. If we want to prime factor 40, we're doing that tree thing, where we want to think of any number that will divide evenly into 40.
20.
Okay, so 20 is 2 and 20. Now, if you say, oh my gosh, I'm terrible at my different multiples.
Oh, 2 goes into 20.
You can pick up your calculator and you can do 40 divided by 20 equals, and it would spit out 2. Okay, and you get your 2 numbers. Then you need to look and see what numbers you have and if you can divide those up.
You can
So,
divide 2 by 1.
can we split 2 into anything?
Yes.
1. When we can only think of a number which is 1 in itself, we say that the number is prime.
So it's prime.
Okay, so our goal, 2 is prime. 2 is prime. Our goal is to get it so that the end of each branch is a number we can't split up anymore.
Okay.
Does anybody know what we call 20, since we can split 20 up? If 2 is prime, 20 is, it has a different word, it starts with a C.
Coefficient.
Nope, that's a number in front of our variable.
Cool.
It is composite. Okay, so what can we split 20 into?
10.
Okay, so 2 and 10. It would also be okay if you picked 4 and 5. There's not a correct answer as long as your math is correct.
These bells are
Okay. We already said that 2 is prime. So now we're going to go on to 10. Can we split 10 up? 2 and 5.
Don't they have to be even?
Nope.
Okay.
Okay, so 5 can't be divided by anything other than 1 in itself. 2 can't be divided by anything but 1 in itself. So we can't split this up any further.
So that's the answer.
So we will then take all of the numbers that don't have a branch coming off of it. Okay, so 2 times 2 times 2 times 5
2 times 2 equals 4.
is our prime factorization of 40.
Oh, 40.
Now, if you were to put in your calculator 2 times 2 times 2 times 5, you better get out 40 because those should multiply to 40. Yes, Bailey?
Couldn't we also write that as 2 to the 3rd?
I mean, you can write it as 2 to the 3rd times 5, but it's technically then not prime. It would have to be instructions that tell you to write it that way, because 2 to the 3rd can be split up into 2 times 2 squared.
So then it's 5, the answer?
This is the answer.
But what if you have to find the greatest common factor of 2?
No, because right now we're just prime factoring. That's one type of factoring we should be able to do. Okay? We can also do the same thing if we are dealing with something that has variables. So if we have something like negative 12x squared y to the third. Now here's a piece that is tough to think through. But what numbers are negative and prime? What numbers are negative and prime?
Negative numbers.
Negative.
So negative 3, do we think that negative 3 is prime?
Yes.
Okay, negative 3 can be negative 1 times positive 3 and positive 1 times negative 3.
So it's
So
not
negative
prime.
3 is not prime.
Negative 1.
Negative 1 is prime. In fact, it is the only negative prime number.
Let's get all smart.
Okay, so if we want to prime factor a negative number, we need to pull out the negative 1. And most of us are happy doing that because we don't want to follow a negative all the way through. And then once we pull out that negative 1, and then we can just start going down the list and prime factoring 12. Okay, so what does 12 split into?
6 and 2.
What does 6 split into?
3 and 2.
Okay, so now we have this added dilemma because now we have some variables we need to deal with. How do we prime factor x squared? Okay, so x squared is going to be x times x.
Times x.
Why is it
No.
We asked you to speak.
Wait, but it's negative 12.
I'm sorry, there's just lots of other conversations going on and it's not fair to anyone who's actually trying to learn.
How you back? How does that make? Negative 1 times 2 times 2
But it's negative 12.
If we were to multiply these things together, we would get negative 12. So that's taking care of the negative 12 portion, the coefficient. X times x gives us x squared because we need 2 x's.
You need y times y times
So then we would need y times y times y because we would need 3 y's. So we're literally just writing down whatever the exponent like that many times.
But it's literally what's up there.
Say it again.
It's literally what's up there. You just take the 12 apart.
Yeah, exactly. Right? This is something that like we start having as a standard in 7th grade. So we should all be like, that should be enough for us to be like, okay, yes, I can prime factor. I can finish that piece. Okay, then we also need a way to find a GCF. Now, I have no problem with you saying that you look at like at 2 numbers or 3 numbers and you see the GCF. If I give you 4 and 16, you should be able to tell me that the GCF is 4.
Yeah.
Okay, however, just like we saw in the POD, when I give you 192 and 288, looking at that and finding the GCF, not so simple. I don't look at that and just see a GCF.
What's the GCF?
Okay, we need to start going through and doing some work. Wait, what were the 2 numbers? 192 and 288. So, here is going to be our process for doing that. And this is where a calculator is your friend. Okay? Instead of just guessing and trying to find a bigger and bigger number, Sarah, can you like put your feet down for me? Let's take notes and participate with class. We are going to look at this and we are going to think of any number that we can think of that will go into 192 and 288. So what's any number that we can think of that will go into both of them? 2. Why do we know 2?
Because they both have
2 can go into
evens.
anything positive.
Even, anything even. So we know these are both divisible by 2. And this is where, right, just like pick up your calculator and do 192 divided by 2. And you'll get 96 and 144. Then you're going to do that again.
Okay.
96 and 144.
Can we do 2 again?
We can do 2 again.
Why not?
72.
Wait, did you just split it into 2?
48.
Yeah.
Say it again.
Did you just split it into 2?
No, I'm taking these 2 numbers. I'm seeing that they're both even, so I'm going to divide them by 2. Okay, so 192 divided by 2 is 96. 288 divided by 2 is 144.
This last one is like,
Okay?
I think we.
Oh my good grief. What goes into 48 that will also go into 72?
2.
That's my line.
Okay, so maybe we see 2, maybe we see 8, maybe we see 4. It doesn't matter as long as it works. I always tell my students, they'll be like, oh, erase, I should have picked something else. By the time you erase and pick a bigger number, you could have just divided again and it's fine. So just whatever you see first, use. So 48 divided by 8 is?
2. Or 12. Or 2. It's 48 divided. Oh, I forgot.
6, 9. He's in jail.
I thought I meant 24 because I thought I was looking at the 2. Oh, okay.
What goes into 6 that will also go into 9?
2.
3.
Yes.
Okay. We need to like get it together. I'm actually kind of embarrassed for some of you. What goes into 2 that will also go into 3?
That's 1.
Okay, so nothing, I'm totally fine with the word nothing, but really they're both divisible by 1, right? That's going to be an important statement later, so we want to make sure we realize that. 1 is just kind of pointless to divide by. So whenever we get to the point that we can't divide out anything else, we are going to take all of the individual numbers that we divided out. So here, 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 here. And we are going to multiply them.
Wait, why'd you put 2 and 3?
6 divided by 3 is 2. 9 divided by 3 is 3. Okay? So we'll take all these numbers and we will multiply them out. Again, you can just use your calculator. You don't need to overthink the math. And if we take 2 times 2 times 8 times 3, what do we get?
96.
Wait. What? 2 times 2.
And we get a GCF of 96. 2 times 2 times 8 times 3 is 96. And we are guaranteed to have the GCF. Okay, because oftentimes my students will find a common factor, but not the greatest common factor. And for several ways that we're going to look at factoring, if you don't get the GCF, nothing else is right. It has to be the greatest one. Yes, Haley?
Keep going till the numbers get lower, and then
Until we
it's like,
can't go anymore. Just keep going until you can't go anymore. Now, realistically, if we're not going to be looking at something that takes us this long to find them, okay? But there are going to be some times you might have to divide more than once. Yes, Gabe?
What happens if there's only one? Like, that you can't.
Then that is your GCF. We're actually going to look at one like that here in just a second.
Oh.
Okay?
Thank you.
4x to the third.
Uh,
16x squared and 8x. Okay, so let's say we're looking at this and we want to find the GCF. Okay, to find the GCF, the first thing we are going to do is just look at the coefficients. What's the coefficient?
The big numbers.
The big number, right? The number in front. So we'll look here, here, and here. So we're going to ignore the variable for a minute. And we're going to ask ourselves what will go into 4, 8, and and 16.
4.
And hopefully we all look at that and realize that it is a 4. Okay, so we'll divide. 4 divided by 4 is 1. 16 divided by 4 is 4. 8 divided by 4 is 2. Then we are going to look at the variable or variables, depending on how many it has. And the first thing is that they will all have to have the variable. So do all of them have an x?
Yeah.
If they do not all have the x, you cannot pull out the x as part of the GCF. Okay, so they all have the x. You are going to use the smallest exponent. So we have a 3, we have a 2, and we have a 1. So since 1 is the smallest, x is what we are going to be pulling out. When we divide with exponents, what do we do? Subtract. So 3 minus 1 is 2. 2 minus 1 is? And 1 minus 1 is 0, which means there's no x left. I'm subtracting because we're dividing, right? And when we divide with exponents, we subtract. There were 3. I pulled out 1 of them. I have 2 left. Does anything go into 1, 4, and 2?
1, 4, 2,
1, 4, 1, which, right, that's when we know we're done. And do they all have the variable?
No.
No, so we cannot go any further.
That's the answer.
Which tells us that our GCF would be all the pieces we pulled out multiplied together, except we only pulled out 1 piece. So our GCF will be 4x.
Does it matter if they have the same exponent or no?
They could have the same exponent. You're just always pulling out the smallest if they all have it. Yes, Bailey?
Why is it always the smallest that we pull out?
Because they all have an x in common. Right? This one doesn't have 2 x's, so I can't pull out an x squared because it only has 1 of them.
Oh, okay.
Now, this entire process, if we do this process to find the GCF, it will actually factor out the GCF for us as well. Okay, which is why I like this process. Because if I then say, okay class, let's factor 16x to the third plus 24x squared minus 40x. Okay, now I'm looking at 3 terms that instead of just finding a GCF, I'm being asked to factor out a GCF. So instead of a comma and the word and, I now have a polynomial. In this case, it is a trinomial because it has 3 terms. So if I want to factor out the GCF, I need to find the GCF. Okay, but by finding the GCF and going through that process, it will take care of all of it for us. So we're going to ask ourselves, can we not handle those seats over there because I've had to stop multiple times? Either make it work or we're moving. What goes into 16, 24, and 40? 8. Now, if you only saw 4, that would be okay. You would divide out 4, and then you would just have to divide again. Okay, so to show what that looks like, let's just pretend that we only see 4. Do they all have the variable? Yes. What is the smallest exponent?
X.
So we are going to divide out a 4x. 16 divided by 4 is 4. We subtract the exponents and get an x squared. Now instead of putting a comma, I'm just going to bring down my addition sign. 24 divided by 4 is 6. X. And then I'll put minus 10. No x left, right? Because it canceled itself out. So now I'm going to ask myself the question again. Is there anything that will go into 4, 6, and 10?
2.
2. Do they all have the variable?
2.
No, so I cannot pull out an x at this point. As long as you do step 1 correctly with pulling out the lowest exponent, you should never have to pull out the variable again. Okay, so 4 divided by 2 is 2. 6 divided by 2 is 3. 10 divided by 2 is 5. Now, I'm going to tell you a small secret. I didn't actually teach you a lesson on how to divide polynomials. This is a polynomial.
Oh, yeah.
Okay? We didn't do anything with dividing a polynomial by a monomial, but you just did it.
Oh.
Right? This was a polynomial divided by a monomial, and you just divide it in all 3 places. So there, now you know how to do that, and there's an Alex topic you also can do.
I think I did.
Yeah, most of you have done it already. You figured it out. It's pretty straightforward, so we didn't do it as an extra day.
Wait, that's a polynomial division?
Right? This is a trinomial divided by a monomial, and we just divided in all 3 places and got this as an answer. That's how you divide a polynomial divided by a monomial. Anything, yes, Chase.
Never mind.
Anything go into 2, 3, and 5?
No.
No. Which means we're done finding the GCF. We're going to multiply these 2 things together. So 4x times 2 is what? Okay, now watch this. Your GCF goes out in front.
Mustache. Yeah, that's what.
And this goes in parentheses.
That's your answer.
This is your factored answer. Yes, Aiden?
Do you have to draw the mustache?
No. No.
Where'd the 4a come from?
I took 4x times 2.
Oh.
Okay? Yes, Bailey?
So if we multiply our factored answer with parentheses, will we get back to what we just
Okay,
did?
so this right here should look like something we already know how to do. Because we've talked about distributing and multiplying polynomials. Factoring is undoing what we learned to do with multiplying polynomials. So if we were to take this and multiply it back in, it would take us right back to where we started up here. So this unit, we are doing everything we learned about multiplying polynomials in reverse. Okay?